Hey guys, my name is Sandeep Patel. I'm a founder of Slaughterify.ca. In this video, we're gonna learn how many different ways we can insert an element into an array, right? Okay, so let's jump in. Okay, so what do we know about arrays, right? So the arrays are they store in the continuous memory, right? And then they have indexes and they also have elements, right? So in this case, we have 9 elements, right, in this array. So the length would be the ninth. And the index is start at 0, which is actually the number of element minus 1 because it's starting at 0, right? So to insert array in the to insert element in the array, there are 3 ways you can do that, right? You can insert at the beginning, right here, or you can insert somewhere in middle, or maybe from here to here, and you can insert at the end, right? So there are 3 different ways you can insert an element into the array, right? So we're going to learn all these methods and their time and space complexity. All right. So when you're trying to insert element at the beginning, how do we do that? Let's look at the visually how we can do this, right? So if we want to do it insert at the beginning, what we need to do is we have to create first an additional space, right? And then we have to copy these elements, right, into these positions, right, on the right. So the 5 comes here, then 4, 3, 2, right? And then the first element will be then empty, right? And that's where we can insert the new value, right? We can replace 2 with the new value, right? So this is the first way you can do insert element at the beginning. What would be the time complexity of this is because that we're adding one spot, but then we iterating the array, right? Like basically we have to iterate from here to here, like from beginning to end. We have to traverse array, like n element we have to traverse, right? And then we have to copy them into the new spot. So that's why its complexity is O of n in terms of time. How about the inserting at index? So let's say we're not inserting in the beginning or not at the end, but let's say somewhere in the middle, right? Maybe let's call this as I, right? Say index I. So an index I equal 1 or 2. How do we do that, right? So in this case, what we had to do is we had to copy elements before this index. We have to insert new element here, and then we have to copy the rest of the elements after that, right? We have to add this, right? So for this, we have to create a new array where we copy the first left elements from the index, and the right elements on the index we will then append. And then the last method is inserting element at the end. This is simple. We can just create a space and then add element right here, right, without worrying about the existing element. In this case, this would be O of 1, right, because we're not moving any elements. In this case, it's going to be O of n, right? Why? Because we're using a new array, and then we're copying the existing elements. So let's look at the code, and you will understand better. Alright, so we have this 3 functions with inserting in the beginning, inserting at the index, and inserting at the end, right? So we call insert at the beginning first. So as I said before, in order to insert at the beginning, we need to first create a new spot, right? So adding a new element, right? Space. So how do we do this? So how are we going to make an extra space, and then we can copy all the element from the left side? So this is pretty simple code. You can do it using for loop. So basically we are looping from the end where array.length, and we will loop until array is greater than 0, right? I plus plus, right? Sorry, I minus minus, because we are coming from the back, right? So just remember that when we have array like this, right? So let's remember this, right? So what is the length of this array? So length in this case is what, 4, right? So when we start and loop with 4, right, position 4, and then we loop until it becomes 0. So how many times we iterate? 4, 3, 2, 2, 1, 0, right? So now look at this. So we had 4 elements before, and now we have 5 elements, right? So we made one extra space, right? Because this is array indexes are 0 based, right? So we added one empty spot, right? So what we do here is that we take the existing array, right? So let's say that we want to insert at the ith position the value at previous element, right? So in this case what happens is, because we created this additional space, right? So when array length is what, 4, right? So 0, 1, 2, 3, and 4th. So we created this additional space here, right? And now we're copying I minus 1, which is, so currently we are at 4th position, so 4 minus 1 is what, 3. So we're basically copying 5 to this new location, right? And then when loops moves, we're copying 4 to this position, and then we're copying 3 to this position, and we're copying 2 to this position, right? Now we have a duplicate at position 1, but we don't care because we're gonna overwrite this, right? So let's look at let's print the array so that we know there is a duplicate, right? Console.log array. And right now this function will complain about return type, so I'm going to return 0 for now. So let's create this void function so that I don't have to worry about this. Okay, so let's run this code. See exactly what happened, right? So now we have first element duplicated, which we can overwrite with our new value, right? So let's say that the 0 element will be replaced with this new element that we're supplying, right? So in this case we want to insert 1 at the first position, right? So that now array will become 1, 2, 3, 4, 5, right? So now if I print, it becomes 1, 2, 3, 4, 5, right? So that is it. So this is how you can insert element at the beginning of array, right? So what is the time complexity of this code? So as I said before, whenever there is a for loop running, we find how many times this runs. So this runs an iteration, right? And then we have one operation, 1 unit of time. So this 1 unit of time operation will be multiplied n times, right? So overall complexity of this for loop is O of n, right? So I can say this statement will be having O of n, order of n time complexity, right? We don't care about this. This will be O of 1. But in big O, we only concern about the bigger term, not the smaller. So this is smaller than this term. So we take this complexity and put it here. This would be our time complexity of this function. And what is the space complexity of this function, right? So when we count the space complexity, we do not count if there are operations happening on the input, right? So in this case, we're mutating the input array, right? So we're not counting this toward our space complexity, right? So we'll ignore this. Also, this is input mutation, so we're not going to count this. So in this case, you can just say that, okay, there's no major variables taken, so O of 1, right? You can say, yeah, there's no major variables that are dependent on input size, and so the space complexity of this is O of 1, right? Now inserting at index, right? So now let's take this example, inserting at index, right? So when we want to insert, let's say that we want to insert at one index, and the element is 2, right? So for example, this is our array, right? And what we want to do is we want to find the index 1, which is 0 1. So we want to find the element 3, right? And then in this position we want to insert 2, right? So this should become like this, right? So now we added 2 at index 1, right? So this is what we should be doing, right? So how do we do that? So at index 1 we first could create a new array, right? So let's say create a new array. So we would create a copy, array copy, let's say array copy, right? And then which is a number array, right? And then what we want to do here at this particular index, we want to first copy all the element that comes before this index, right? So we're gonna run a loop, for loop, let I be 0 until I less than this index, right? I less than this index, I plus plus, right? And we will append those, we will copy those elements. So at this index we are copying existing array elements, right? So let's do console log and see what happened. Okay, so this code, what it does is it's copying this 1, right? So let's say this should be our output, right? Okay, so this is exactly what it does, right? And now we're at the index, right? So we can just say at I plus plus, we're increasing the index, or maybe you can just say array length, right? Like the copy array dot length, because it's gonna have only one element, right? And because it's a 0-base index, it's perfectly fine, right? It's gonna insert at the location that we want to insert, and then we add this element at that index. So what we did here, we inserted at index I, or element that we want. So now this array will become 1 2, like this. Let's run. So now it becomes 1 2, right? And then what we do now is we will copy the rest of the elements after index, right? So we will start index plus 1, right? So all the element that is after that index, and then we run until array.length, sorry, at the same index. We also want to copy number 3 as well, right? So what we're doing here is that we're copying but we want to make sure that we don't want to override this, right? So because we already inserted an element here, so this should be I plus 1, right? Okay, and now let's check what happens. So far we had like this 1 2, right? And then now what we're doing is we're copying 3 4 5, right? So let's look at what it does, right? So we copied all those 1 2 3 4 5, right? So that is it. And so this is how we can insert element at particular index, right? So let's look at the time and space complexity of this code. So for time complexity, we're going to ignore this variable, right? Because variables we don't care at this point. What we care about is that how many times this loop runs, right? So it's gonna start from 0 and it runs until index, right? So this index could be from the starting until until the last element, before the last element, right? Because there's a, we already have a method to insert at the end, so we care about n minus 1, right? So this goes n minus 1, right? And similarly, after index, let's say if we're inserting here, so from this index it runs until end of the array, right? So in this case it started at index I and it loops until index loop until the end of the array, right? So you could basically replace this with n, right? So it takes n iteration, right? If we ignore minus 1, this is also n iteration. So if we find the overall complexity of this loop, so there's one statement that takes 1 unit of space, right? We have the similar thing here, right? So overall complexity of this for loop and overall complexity of this loop is the same, right? N times 1, which is O of n. So that's the time complexity of this code. And if we calculate the space complexity, basically we are creating a new array. So when we declare a new array, right, which grows dynamically in the size, that counts towards space complexity here, right? So we created an array which has a dynamic size, and then when we are looping through an iteration, we're appending elements in this array. So this array copy is growing dynamically. And how much it will grow? So it will go n iteration, right? So from 0 element until the nth element, right? So you can say the space complexity for this code is O of n as well, right? So inserting at index takes O of n and O of n space, right? And how about the inserting at the end? So this is pretty simple. We can use the similar logic like this, right? So basically we take the existing array, and what would be the array length, right? So array length would be the number of elements, right? And because it's a 0-based index, let's say if there are 10 elements in the array, right? So the length would be 10. However, there are actual 9 elements, right? Because the array started at 0 index, right? So let's say if we want to add an element at this in this array at the last position, what is the total element? 1, 2, 3, 4, 5, right? So there are 5 elements, so the length will return 5. However, how many actual elements are there if you count from the index? So 0, 1, 2, 3, 4, right? So there are only 4 elements if we are counting from 0 index, right? So this array length would be, in this case, 5, right? So we're making an extra space, and then we're just adding this new element there, right? And if we print this array, so it's going to properly insert element at the end, right? So let's call this function, right? So we have array 1, 2, 3, 4, and then we are adding a new element at the end. So it should be 1, 2, 3, 4, 5, right? So let's run. Okay, so it is inserting element properly at the end, right? And that is it. This is how you can insert a element in array. There are 3 methods that you can insert at beginning, at index, and at the end. What is the space and time complexity here? You can clearly tell that no matter how many times you run this function, this line of code will output, run 1 time, right? So the complexity is O1, and also space complexity is also O of 1, because we are not using any additional variable like this, right? So that is it. I hope you enjoyed this video. Please like and subscribe. Thank you.